So what we see here is the human brain. And now this is a neuron. You might be wondering what a neuron does. A neuron, well,
It helps transfer any and all types of signals from itself to another one of its kind. In the similar way, the neuron of an AI works, except rather than just carrying over the signal, the neurons of an AI slightly change it using something called weight or just W. But what is W? How does it work? How does an AI even function? If you are curious, then you are at the right place. Now, this is the neuron of an AI. Here, X is the input and Y is the output, and W or weight is the variable that affects the output by multiplying itself with the input in the single neuron system. How is the W or weight decided? Well, by a very simple formula of W equals to W minus gradient into LR. This LR is a short form of learning rate. And fun fact, learning rate is generally 0.01. But we have complete authority and command over what the learning rate should be.
as for gradient, it's like a detailed feedback on a term paper, pointing out every tiny mistake. It's not about grading your work with a simple pass or a fail. It's more like here's precisely how much and in which direction you missed the mark on question 3 paragraph 2. This detailed feedback is crucial because it tells the AI exactly how off its predictions are from the actual outcomes. In other words, the magnitude of its errors. You may think of it as a personal trainer for the AI, saying you're lifting weights perfectly, but let's adjust your elbow angle by 2.5 degrees on your left arm for optimal performance. The AI then tweaks its parameters slightly, reducing the error bit by bit, aiming for our sweet spots where its predictions are as close to perfect as possible. It's a bit like trying to fine-tune your dance moves in the dark, guided only by someone saying warmer or colder. You're gradually getting better, even if you occasionally step on some toes along the way. So the gradient in AI isn't just about pointing out errors, it's about offering a roadmap for improvement, ensuring the AI model learns gracefully from its own blunders, much like us humans, except with, well, much less tripping on our own feet. Now we have only seen the example of only one neuron, but how about a billion or more? Imagine if a single neuron in an AI was like having just one worker in a huge office. Sure, he can do some tasks like make coffee or answer a few emails, but it's not going to be the buzz of productivity you'd expect. Now imagine you have not one, but tens of billions of these workers. The office is buzzing, tasks are flying off the charts, and there's a kind of magic in the air. Because now they can tackle anything from organizing the world's craziest office party to solving mysteries like where the boss's favorite pen went. This is what happens in AI land. A single neuron, much like a lone office worker, has its limits. But bring together billions of them and you've got a powerhouse team. Like ChatGPT, think of it as a office superstar, always on the ball. And then there's Gemini, the office clown. Always good for the laugh, but not quite the productivity machine. For the secret sauce to making an AI smart isn't just having a ton of these neuron workers, but how well they work together, turning a solo task into an office-wide orchestra that can play the sweet symphony of getting things done in the most complex and efficient way possible. It's teamwork on a whole new level, really.
Now, talking about something not many people talk about really is when it all started. It all started in the world without a smartphone or social media back in 1943 with two curious minds, Warren McClough and Walter Pitts. These pioneers crafted the first concept of a neural network, imagining a computer that could think like a human brain. Imagine that using pencil and paper to sketch the future of AI. Fast forward a bit, and along comes Donald Hebb in 1949, throwing a curveball with his idea that the brain's connection gets stronger the more they are used. This was the spark for Hebbian learning, kind of like the practice makes perfect for AI brains. Now jump to 1980s, a decade known for big hair and even bigger ideas, where Geoffrey Hinton
Jeffrey Hinton.
And his squad revolutionized how these artificial brains learn, introducing backpropagation. This was the game changer, teaching AI to learn from its oopsies and get smarter over time.
These tailblazers, along with many other unsung geniuses, laid the groundwork for the AI superstars we chat with today, like ChatGPT, and even quirky ones like Gemini. Their relentless curiosity turned the dream of machines that can think into a reality we are still exploring. So, as we dive into the story of AI on our channel, let's give a nod to these pioneers whose big questions pushed us closer to answering, can machines think? Now that we have learned how a single neuron of an AI works, we can now talk about how advanced AIs like ChatGPT or Gemini work, using the basic concepts that we have discussed earlier in the video. Models like ChatGPT and Gemini operate on the principles of neural networks, which are akin to digital version of human brain's neural pathways.
This process leverages the chain rule of calculus, allowing the network to understand which weights need adjusting to minimize future errors, thus enhancing the model predictive accuracy with each iteration.
ReLU has become a favorite for its ability to maintain a healthy gradient flow. Well, now the question of what is a healthy ReLU arises. A healthy ReLU is where logic does not exist or is turned down a notch, so that by allowing positive inputs to pass through unaffected while negating negative inputs. This characteristic is particularly beneficial for deep networks, helping to mitigate the vanishing gradient problem. The sigmoid function, meanwhile, compresses input to a range between 0 and 1, making it ideal for tasks that require outputs to be interpreted as probabilities, though it's more vulnerable to the vanishing gradient issue.
By harmoniously integrating these mechanisms, neural networks, gradient descent, backpropagation, and activation functions, AI models are empowered to learn from vast datasets, continuously improving their performance. This intricate dance of algorithms and data processing allows AI to master complex tasks, making it an invaluable tool in our quest to replicate and understand cognitive processes.
And this is how an AI works. Thank you for staying till the end of the video.